I had a few requests to go over some of the examples on this worksheet, so I wanted to go over a few of them. It's a great opportunity to go over binomial and geometric distributions, as well as calculating expected value. So one thing I recommend, have your TI 84 or 83 handy for this. It's going to be very helpful. All right, so let's take a look at the first question here. It's the probability that the first 4 times we go, we get a purple ball, or we're given a purple ball. Now, if I look up here, probability of getting a purple ball is 12%. So this would be a case of a geometric distribution because essentially you're succeeding. And actually, this wouldn't necessarily be geometric because there's no failure here. There's no succeeding until you fail, failing until you succeed. All we're trying to calculate is the probability something happens 4 times in a row. So since these are independent events, because getting a purple ball isn't going to be affected each time, probability of getting it the first time, 12%. Probability of getting it the second time, 12%. Third time and fourth time, doesn't change, 12%. You could have done, 12% or 0.12 to the fourth power, same exact thing. So we'll just calculate this quick, and we get a very small probability. Reason why? Probability of getting it the first time, 12%, isn't very high. Something that's 12, probability of it 12% happening 4 times in a row, it's gonna be pretty low. So I ended up getting something. It was in scientific notation, but this is pretty darn close. All right. Ooh, this one's a trickier one. Probability that you're given black, then not black, then red, then not red. All right, so let's start with the probability of getting a black ball here. So I'm going to use a different color to highlight here. Probability of getting a black ball is, let's see, 8%. Okay. Probability of that happening the first time is pretty straightforward, 8%, 0.08. Now, the second time, that's that I'm not given black. So if 8% of the time it happens, 92% of the time, it doesn't happen. Then red, probability of getting red would be 16%. Then not red, that happens 84% of the time. Again, to get these complements, all I did was I took the original probability, subtracted it from 1. So I did each time. Took the original probability, take it away from 1. And this is just a straightforward multiplication problem, which again, highly recommend you have your TI handy for this. And boy, you get something pretty low here. Because again, this is a very specific combination. You're not expecting it to happen very often. 0.0098 I got. Hopefully you're getting the same thing. Okay. Now we get to something that's a little bit more specific here. We get a binomial distribution. How do I know? It says if I go 50 times, probability that I get exactly 30 green golf balls. Now, those 30 can come in any order out of 50. There are a lot of different combinations I could get. So the way I account for that, I use the combination function on my calculator. So total number of trials, 50. Looking at 30 successes. Each time I get a green ball, it's considered a success. So a green ball happens 19%, so 0.19. Well, I see that happen exactly 30 times, which means if it's not happening, then that's going to happen 20 times. So 30 plus 20 gives me my 50. Again, I went with the complement. That happens 19% of the time, doesn't happen 81% of the time. So now I'm going to use the combination function on my calculator. Some of you might be using Binomcdf. That's fine. I prefer using the combination function just because it lends itself more to the formula that you're probably going to end up seeing on the exam. So it just takes a little bit of work to get there. Just plug in some numbers. You might already be there, especially if you have one of the more modern calculators. And let's see what happened. I'm going to delete that. Whoops. Oh boy, I got a very low probability. Chances are you did too. Reason is, 19% of the time you're expected to get a red ball. And it happened 30 times, the probability is pretty low. I ended up getting 1.6 times 10 to the negative, negative 10th power. Sometimes you're going to get low answers. That happens. Okay. All right. Now I want to touch on number 4. Number 4 is a really good one here. Tell me I go 20 times. What's the probability that I get less than 5 are going to be black? There are a number of ways I could do this. Here's one way. I could write out all the different combinations. I could go, all right, 20 trials. It could happen none of the time I get to that black ball. And let's just double check the probability of getting black here is 8%. Okay. So that means I could do 0.08 to the 0 power, 0.92 to the 20th. Then I'm going to add, because it's telling me less than 5. I could go 20, and then it happens once. So 0.08 to the first, and now 0.92 is going to be to the 19th now. And I can keep going with this. I can just keep writing these combinations, keep adding up these different combinations. So I did it for 0, 1. We do it for 2, 3, 4, all the way up to, it says less than 5. So the highest I'd have to go up to is 4. That's a lot of combinations. You could do it that way. A lot of teachers recommend you do it that way. I think it's a great way of getting there. However, another way you can do this one's a little bit easier. You can use that Binomcdf function. Now this is dangerous. You gotta be careful with it. So I'm going to show you how you would use it here. Binomcdf. Notice how I'm writing the function out. So I'm going to get to that on my calculator. Going down, gotta find it. All right. Now it's Binomcdf because it's cumulative. So I'm looking at 20 trials. Probability of success is 0.08. And the highest number of successes I want here. I want 0, 1, 2, 3, 4. 4 is the highest. So that's the value I'm going to enter in for Binomcdf. So again, 20, 0.08. And then the highest number I want is 4 here. Plug that in, and I get, looks pretty high. It's a pretty high probability. 0.98. Now, the reason is, again, they're asking, like, you could get 0 times, 1 time, 2 times, 3 times, 4 times. That's quite possible considering it's a small probability. So this answer makes some sense. So I wanted to go over that because that's a great use of the Binomcdf function. Now, in this case, if you're looking at least 10 that are pink, all right, so let's see, we got 40 trials. And it says at least 10. So I could go from 10, and then I got to figure out probably getting a pink ball is, let's see, 11%. And we're saying at least 10. So I could go from 10. And then for my complement here, I'm going to use 30. So I could just keep doing this because it says at least 10. Then I would add 40, 11, do the same thing. 0.11 to the 11th. 0.89 to the 29th. You see, this is a lot of work. I'd have to write out a lot of these to do this. Because I'd have to go all the way up to 40. ... That is a lot of different combinations here. You can do it that way. Some people recommend you do it that way. The issue is it's going to take a long time, as you might be picking up on. Oh, and that's supposed to be a 0. It almost looks like a 1. Boy, that could take a long time. If only there was an easier way to get there. But there is. I can figure out everything from 10 to 40 and add it all up. Or, follow me here, I can figure everything out from 0 to 9 and take that away from 1, which is 100%. Figure out the percent of the time it happens 0 to 9. Taking that away from 100% gives me everything from 10 to 40. I think that's what I'm going to do here. So what I'm going to do is I'm going to do 1 minus Binomcdf. Remember, Binomcdf calculates all your successes from 0 up to the given value. So I'm going from 0 all the way up to 9. And that'll give me my answer here. So I'm going to do that out. I recommend you do the same. And after this, I'm going to do one more problem. 40. Again, my success, 0.11. Oops. And then comma, 9. And I get 0.0098. One thing I forgot to do here, if I'm using this calculator function, I always want to label what these values are. I don't want to just plug this in. So you notice right below here, this is what you always want to do, especially on the AP exam. Number of trials. I know it's really thick, but that's okay. Underneath this one, I'm going to put probability of success. And then here I'm going to put highest number of successes. Always label when you're using calculator functions. Be very specific. You want to show that you don't know just how to use calculator functions, you know what you're doing. Here's the last question. I got someone asked me about this one. If you play mini golf 50 times, what's the expected number of green balls? With what standard deviation? Okay, you got a couple ways you can get here. I'm going to show you. So it's telling me green balls, 19%, right? Expected number is easy. All I got to do is, I'm going to use a thicker, okay, too thick, but that's okay. 50 times 0.9, expected 19% of the time. This will give me my expected value or my mean. These are pretty easy. Don't be thrown off by these questions. All right, I get 9.5. Okay. What's the expected number of green balls? With what standard deviation? Now, standard deviation can be a little trickier. However, what I always do is when all else fails, notice how I'm going to my Schoology page here. I'm going to look for my AP formula sheet, course materials, formula sheet. And also, I'll give it to you. Binomial distribution. See, it gives me my mean. And then my standard deviation. Oh, this is nice and easy. When all else fails, always come back to this. So I'm going to take total number of trials times the probability of success times the probability of failure and find that square root. So I'm going to go back and do this. Okay, so now I'm going to do square root of probability 0.19. Notice I did total number of trials, and then probability of failure is 0.81. Find the square root of that. And just to double check, I'm going to go back to that formula sheet. Yep, perfect. When all else fails, always use that formula sheet. You don't have to memorize this stuff. So now just plug it into your calculator. Square root of 50 times 0.19 times 0.81. Oh, almost entered in the wrong number. And I get 2.773. So I'll just do 2.77. So if I play mini golf 50 times, I'd expect to get like somewhere between 9 and 10 green balls. And typically it will be almost 3 above or below that average. So I could expect anywhere from 6 to 12, somewhere in that ballpark. So I hope I was able to walk you through a few of these problems and give you the idea of how to use some of these binomial functions as well as using some of these formulas. Best of luck on this assignment.